say converse, I don't mean the shoes. We're talking about the converse of the Pythagorean theorem. So we know, Pythagorean theorem, a squared plus b squared must equal what? C squared. And we know that we only use the Pythagorean theorem for what type of triangles?
Right triangle.
Right triangles. Only for right triangles. So the converse states that if a squared plus b squared equals c squared, then if it's a true statement, we're talking about a right triangle. So we can use the converse to prove that three measures of a triangle in fact form a right triangle. For example, supplemental. If we have 3 squared plus 4 squared, if this is a right triangle, this has to be 5 squared because we need a true statement. True statement, remember, right? Same thing on both sides. So let's see. 9 plus 16 equals 25. What's 9 plus 16? 25. So if you solve this for 3 measures and you get a true statement, that means we're talking about a right triangle. However, if we did this, 3 squared plus 4 squared equals 10 squared, are we talking about a right triangle now? No, we're not, and here's why. This becomes 9 plus 16 equals 100. Does 25 equal 100? No, it's false, so this would not be a right triangle. Still a triangle, but if these were the side lengths, this would not be a right triangle, okay? So that's what we're doing here. Now, the way you have to set this up is you first have to remember that the hypotenuse is always the longest or largest side. So if I gave you 3 measures, 8, 17, and 15, which one of those has to be the hypotenuse? 17. And then you set up your equation like this to test and see if it's true. It would become 8 squared plus 15 squared. These are my legs because they are the smaller measures. Hypotenuse is always the largest one. So I do 8 squared plus 15 squared equals 17 squared. If I get a true statement here, that means that this is in fact a what? A right triangle. If I get a false statement, it is not a right triangle. Question?
Why is the hypotenuse in the middle now?
Hypotenuse wasn't in the middle. I just rearranged the numbers. The hypotenuse, when you set up the equation, where's the hypotenuse? I was just giving you 3 different measures. If I put them in order, it's too easy to see. But if I gave you 3 numbers, such as, let's just do this. Let's do 17, 6, and 15. Which one of these has to be the hypotenuse? 17. So the reason I rearrange them is so it wasn't just given to you in order. You have to know that whatever the larger value is, that's going to take on the role of the hypotenuse in your equation. So what if I gave you 100, 99, and 101? Which one is the hypotenuse? 101. The other 2 would be the legs. Okay, you get where we're going? And we're checking to see if we get a true statement. So here, somebody had a question?
What if they're the same number?
They can't be the same number because it has to be the largest side. So if you had something like this, here's how you can test it. This wouldn't be true. 15, 15, and 50. Here's why it wouldn't be true. 225, right? 15 squared plus 15 squared equals 15 squared plus 225. Is that going to equal 225?
Oh no.
No. There's no way they can all be the same size. That's not a right triangle. And it would actually, think about it. Would that form a triangle? You tell me.
Yeah.
Try to see if you can do that. Try to take 3 lines that are the exact same size and form a triangle out.
No, you can't.
Basically,
Wait.
be a want to be square without one side.
Yeah, you can. If they're all the same size, you can't form a triangle out.
Wait,
Can the
wouldn't
2
that be?
legs
Oh, sorry.
be the same numbers?
In a right triangle? In a right triangle, I think the only thing that would satisfy that, actually, if I'm thinking about it here, the only thing that could possibly satisfy that is if we had, no, that wouldn't work. I'm trying to think if there's any scenario where that would work. 2 squared, 2 squared. I mean, technically speaking, right, you could do something like this, 2 squared plus 2 squared, right? That's going to give me, you'd have to try to find the number that would be on the other side. 3 and 3 makes 9 and 16. I don't know, you'd have to go and find one. I've never seen it where they're the exact same, but possibly they could be, right? Because technically speaking, we could do this and this, right? So if this is 3 and this is 3, technically speaking, that would be 9 plus 9. So this would have to be, whatever this number is, somebody tell me what's the square root of 18? It would be a weird number, but I mean, is it technically possible? Yes, but you see it as 4. So it would be technically, here's what we'd be doing. 9 plus 9 is equal to the square root of 18. Is it possible in theory? I guess so. Will you see it at this grade level? No, that's something you'll probably talk about more in geometry. Okay.
Take a voice to school.
Okay. Anyway, so here we're solving this. 8 squared plus 15 squared. That's gonna give me. No, hold on. 64 plus 225 is equal to
289.
289. We add these together, I get 289 equals 289. Is that a true statement?
Yes.
Yes. It's a true statement that says, it's really small. True statement that says these are in fact a right triangle. I'll write it bigger. It's true, which means it's a right triangle. Okay? So we take the three values, we're trying to see if we can get a right triangle out of them. How might you see this? How might you apply it? You might be given a series of 6 numbers like this, and you might be asked to pick 3 values that would form a right triangle. The way to solve this problem is to take each of these numbers and square them, right? Because if you're using the Pythagorean theorem, don't you have to square all these numbers? And then what you do is you take 2 of the smaller numbers and see if you can get them to add up to equal one of the bigger numbers. So if I square 9, 8, 11, 12, 10, and 15, I get 81, 64, 121, 144, 100, and 225. So looking at these 6 numbers, are there any 2 of the smaller numbers that if you add them together would equal one of the bigger ones? Let's see. If we take 64 and 81, that equals 145, which is not one of these numbers. So that's false. There's no right triangle possibility here. If we take 81 and 121, that gives me 202. That is false. No right triangle there. But what if we added 81 and 144? What do we get?
225.
225. So 81 and 144 equals 225. That's a right triangle. So the 3 measures that would work, 9, 12, and 15. Those would form a right triangle. You square them, and you identify which 2 smaller values will equal a larger value. This question here, just with different numbers, you might want to put a star next to it. You know where you'll see it again. Don't forget to like the videos, leave a comment, share it with your friends, and of course, subscribe.